Honors Pre-Calculus students, this video is about trig identities. I'm going to introduce the fundamental identities in this video, but overall we are in Unit 3, Topic 3, which is all about identities. What is fundamental identities, proving sum difference identities and multiple angle identities. But we are only going to cover in this video the first objective, which is the develop, state and apply fundamental identities. Apply part we will do in class, but I'm going to talk about what are they. So what is identity and why it is so important? So identities are important because in calculus so many trig functions we have to rewrite them and we simplify them using identities, and it makes our work easier. So to add some fun part is we always say that you have to remember these identities, and just to add some humor that protect yourself from identity theft. So let's see what we have. We have very interesting lesson in this video. So this unit is all about fractions and factors. You need to have a really good skills on factors and fractions. If not, we can review how do we factor so that we can write it as a 2 binomial. Also, you have to review the fractions. What is a fraction over fractions? How do we simplify? So be careful, you can review all this. I'm going to jump on straight to the identities. So what's the difference between identities and equations? There are many different types of mathematical equations. So this is called name of the equation. This is a name, f of x is the name of the equation. Conditional equations, which we have two sides, it could be true or false, but it is true only for finite number of values. So this is name equation. We can just give the name. This is we have two sides, true only for certain number of values, certain values of x. So that's a conditional equation. Contradictions are we equate two expressions, but they are never equal to sign. For example, 5 equal to 7 is never true. Square root of x plus 1 is never going to be ln x. So this is a contradiction. And let's talk about the identities. So we know all this before. Now, identities is true for all values in the domain of both expression. That is called identity. That means it's always true. For example, in the previous unit, we have seen square root of x square is absolute x. This is always true for the domain of both expression. Domain of absolute x is all real number, domain of x square is all real number. If you look at this one also, 7 plus 1 is 8, e to the 0 is 1, and 10 minus 2 is also 8. So these are identities. Identities are important because two equated expressions serve as a mathematical synonym each other, meaning one may be substituted for other without losing generality. So we are going to begin by looking at fundamental trig identities. We call them fundamental because they involve trig expression and are basic. The other more sophisticated identities can be built from using them, which are going to be bigger, better and bolder identities. There is no such word as a better, but some are really good ones, some are really complicated. That's why we call them bad. So today we are going to look at again basic trig identities. I call them know them all the time, memorize them, but it's nothing really difficult there that you have to memorize. So let's take a look at first one. We have seen them as reciprocal functions, but we are giving them a fancy name of identities. We know that cosecant theta is 1 over sine theta and sine theta is 1 over cosecant theta. So I would put a smiley face here that we got it. I think we are confident that we know this. We are confident that we know cosine theta is 1 over secant theta. Secant theta is 1 over cosine theta, reciprocal of each other. Same thing with cotangent and tangent. So we got that part covered. Next one is quotient identities. What is quotient identities? Quotient identities, we call them as a ratio. Until now, we knew that tangent theta was always y over x. But we also know that the y is always a sine and x is always cosine function. So that is same as y over x. Cotangent theta is the same as x over y, because we have learned in the previous unit that unit circle always have a coordinates which are cosine and sine. So same thing, we just put them as a ratio. So I would put a smiley face here as well. We got it, we are confident, we know, we have learned them before. We are just giving them a fancy name of identities. They are functions. We put them because they both sides are true always. Okay, so let's talk about odd even identities. Isn't this odd even functions? We have learned that sine of negative theta is a negative sine theta. Cosecant negative theta is cosecant theta because these two are odd function. We know that cosine is a even function. So this is a even and this is an odd function. So let's review quick about odd and even function. If f of negative theta is f of theta, then it's an even function. F of negative theta is negative f of theta, then it's an odd function. So this is even, that's the odd. So I would say this is also we got it. Yeah, but sometimes we make mistakes. I would put a straight face there, that you have to be careful about them. Let's take a look at the last one. Co-function identity. Co-function, the co, where that co come from. So let's take a look at this one. Sine of pi over 2 minus theta is cosine theta. Cosine of pi over 2 minus theta is a sine theta. And tangent becomes cotangent. Where this comes from is straight from the triangle, and I call them, if this is a theta, then the other side, this angle will be 90 minus theta. Agree? Because this is a 90. So if I'm using SOHCAHTOA, then opposite edges cosine theta is nothing but the same as 90 sine minus theta, because they are complementary angles. Sine pi over 2 minus theta is cosine theta. Let me give you another example. Let's say sine 30 is 1/2. But we also know that cosine 60 is also 1/2. What's the relationship between these two? 30 and 60 are complementary angle. That's why sine 30 is the same as cosine 60, and that's where the co come from. Co. Complementary of sine is a cosine theta. Sine is a cosine, tangent is a cotangent theta. The co is from complementary angle. So I would put a straight face here. This can be proven using the graph also. If this is a sine theta graph, I can see that if I shift pi over 2 unit, then it becomes the cosine theta. So you can see from the graphical point of view, as well as the complementary angle from the unit circle value point of view, as well as later on we are going to use the sum difference identity and we are going to prove it. So be very careful about this. Now sometimes you will see that sine of theta minus pi over 2. Do you think that's also cosine theta? That's not cosine theta, that will be negative cosine theta, because again you know that a minus b is never same as b minus a unless it's the even function. So this is not You cannot switch those theta minus pi over 2, pi minus 2 theta. They are not true because this is odd function. If it is a cosine theta, yes, you can say that cosine theta minus pi over 2, which is the same as a sine theta. Again, the properties here we are applying is this cosine is even function. So be careful if it is switched. You have to, sometimes you will see the combination of these two together, and that's what this is here. Make sure you take a notes and write this down on a notebook. So let's talk about Pythagorean identity. So once identity has been proven or established, it can be algebraically modified to take on a different form. So what does that mean is, look at this example, sine theta is 1 over cosecant theta. But can we multiply them together and make it 1? Yeah, we know that the reciprocal, if you multiply the reciprocal, you get the 1. The product of reciprocal is always 1. The product of reciprocal function is always 1. That's the again reason we call them reciprocal. So that is true for powers as well. If I say sine square, I can substitute as 1 over cosecant square. If I say sine to the fifth over cosine to the fifth, I can easily say that is equal to tangent to the fifth. So all those identities work for higher power as well. So let's see, what is Pythagorean identities? The name itself comes from Pythagorean identities. So what is Pythagorean identities? And this is the most often used. It's coming straight from the unit circle. If I put the point on a unit circle, the radius is a 1. X is a cosine theta. If I put this as a theta, Y is a sine theta. So why we call them Pythagorean identity? Because we know that x square plus y square is equal to 1. If I replace x with cosine theta square plus sine theta square is equal to 1. Okay, so writing in trigonometry is a little bit tricky. Since we have to write so many parentheses, it's very common that we write cosine square theta plus sine square theta is equal to 1. Notice that the second power we put it on cosine. You never write this. What this means is angle theta is being square. That's not what we are talking about here. Function cosine theta value and sine theta values are being squared. To avoid the writing parentheses, we write it cosine square theta, and that is our first Pythagorean identity. Cosine square theta plus sine square theta is equal to 1. Most common mistake is students are taking square root and they write cosine theta plus sine theta is equal to 1, which is not true, This is never, cannot take a square root. This identity is only true for 1 square. You should write 1 square because that's what it is, 1 square. So you cannot take a square root. These Pythagorean identities are only for squares. You can never write as a fourth power. Again, another common misunderstanding. Students say cosine to the fourth, sine to the fourth is 1, which is not true. Because this is only true if the power is a square, because Pythagorean rule is x square plus y square equal to z square. So very careful about how do we write. Okay, so the other two, there are 3 Pythagorean identities. Where the other 2 come from? Other 2 comes from modification of this. So let me show you first one here. If we know sine square plus cosine square equal to 1, I wrote wrong backward. Let me rewrite. if we know cosine square theta plus sine square theta is equal to 1, we divide each term by cosine square. Let's say we divide each term by cosine square. Then cosine over cosine is a 1, sine over cosine is a tangent, and 1 over cosine is a secant square, and that is our second identity, which is Pythagorean identity but written different way. 1 plus tangent square is a secant square. Again, all these identities are only true for squares. They are not true for any other power. So you get the idea where the third one is coming from. The third identity is coming from, you divide each side by sine square. Let me clean up just to show you. If we divide each side by sine square, cosine square over sine square is a cotangent square. That's one fitting here. This one comes here. You can see that cosine over sine is cotangent, sine over sine is a 1, and 1 over sine is a secant square. So, well, we have learned so many different identities today. One is Pythagorean identity, basic one. If we divide everything by cosine square, we get the 1 plus tangent square, and if we divide everything by sine square, we get cotangent square plus cosecant square. Now, easy way to remember is, I have also explained before that cos are related. Cos, cotangent, cosecant square are related. Tangent and secant are related. Well, sine cosine is based on xy and radius 1, but the cos are always together. These cos are always together. So why all of a sudden we bring theta, sometimes we use x, what's going on? So we can use x in place of theta. All the time we were using x, theta, know that that's angle in radian. That's angle in radian. Cosine square x is a condensed way to write. The entire ratio is a square. So know that I explained in a few minutes ago here. How do we write? Cosine square is the same as cosine square x is the same as the whole ratio is being square. So before we start using our new fantastic identities to prove other identities and solve equation, this is upcoming. So you need to know the difference between verify and proof. So we will use this again in the next video. Make sure you understand and you remember all these identities and use them. The only way we remember is we keep using them. If you use them, you will not forget it. So one more time, let's take a review. What we learned today is whole new set of basic trig identities. We give them a fancy name of identities because we know them as reciprocal functions. Tangent, cotangents are the quotients, are the ratio. Odd even functions, we write them as odd even identities. Co-function identities comes from the complementary angle because angle of sum of the two angles is 90 degree and that's what it comes for. And on this side we learn Pythagorean identities. So next lesson we will start using them. Thank you so much.